Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. CS 3352 Foundations of Data Science, Unit 5 Data Visualization. In this presentation, I'm going to explain the topics Geographic Data with Basemap and Visualization with Seaborn. The first one is geographic data with Basemap. One common type of visualization in data science is that of geographic data. Matplotlib's main tool for this type of visualization is the Basemap toolkit, which is one of several Matplotlib toolkits which lives under the MPL_toolkits namespace. Installation of Basemap is straightforward. We can install the Basemap like using this coding conda install Basemap. You can import numpy matplotlib.pyplot, and also we have to import all these packages from mpl_toolkits.basemap imported from Basemap. Once you have the Basemap toolkit is installed and imported, geographic plots are just a few lines away. The graphics in the following also requires the PIL package in Python 2 or the Pillow package in Python 3. For example, we have written the coding here. plt.figure of size is equal to 8,8 and Basemap projection is equal to ortho, and then the map is blue marble. Scalar distance is 0.5. The output for the above code is shown here. The useful thing is that the globe shown here is not a mere image. It is a fully functioning matplotlib axis that understands spherical coordinates and which allows us to easily overplot data on the map. Next one is kinds of map projection. There are different types of map projections we are going to see in this presentation. First one is cylindrical projection. The simplest of map projections are cylindrical projections, in which lines of constant latitude and longitude are mapped to horizontal and vertical lines respectively. This type of mapping represents equatorial regions quite well, but results in extreme distortions near the poles. The spacing of latitude lines varies between different cylindrical projections, leading to different conservation properties and different distortion near the poles. Here is an example for cylindrical projection. See here, projection is equal to CYL represents cylindrical projection, and the map is shown here. Here we have shown the example of equidistant cylindrical projection, which chooses a latitude scaling that preserves distances along meridians. The other cylindrical projections are Mercator, short form is MERC, and the cylindrical equal area projections. A cylindrical equal area is equal to CEA. Instead of writing CYL, for Mercator projection, you have to use MERC, and for cylindrical equal area projection, you have to write within quotes CEA. The example is shown here. The additional arguments to Basemap for this view specify the latitude and longitude of the lower left corner and upper right corner for the desired map in units of degrees. Next type is pseudo-cylindrical projection. Pseudo-cylindrical projections relax the requirement that meridians, lines of constant longitude, remain vertical. This can give better properties near the poles of the projection. The mole-wide projection is one example of this, in which all meridians are elliptical arcs. See here, projection is equal to MOLL. It represents mole-wide projection. The extra arguments to base map here refer to the central latitude and longitude for the desired map. Other pseudo-cylindrical projections are the sinusoidal and Robinson projections. For sinusoidal projection, projection is equal to, you have to write SINU. For Robinson projection, you have to write projection is equal to ROBIN within single quotes. Next one is perspective projection. Perspective projections are constructed using a particular choice of perspective point, similar to if you photograph the earth from a particular point in space. A point which for some projections technically lies within the earth. One common example is the orthographic projection. Projection is equal to ortho, which shows one side of the globe as seen from a viewer at a very long distance. As such, it can show only half the globe at a time. Other perspective-based projections include genomic projection, that is projection is equal to GNOM, and stereographic projection, that is projection is equal to STERE. These are often the most useful for showing small portions of the map. Here is an example for orthographic projection. Projection is equal to ortho, O-R-T-H-O. It should be written within single quotes. And latitude and longitude are specified for the desired map. The output is shown here. And next one is conic projection. A conic projection projects the map onto a single cone, which is then unrolled. This can lead to very good local properties, but regions far from the focus point of the cone may become very distorted. Here we have written the projection is equal to LCC. And longitude and latitude are specified, width and height are specified. Other useful conic projections are equidistant conic projection and the Olbers equal area projection. Conic projections, like perspective projections, tend to be good choices for representing small to medium patches of the globe. Next topic is visualization with Seaborn. Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. The key features are Seaborn is a statistical plotting library. It has beautiful default styles. It is designed to work very well with Pandas data frame objects. To install Seaborn, we have to use this pip install Seaborn. It is also possible to install the released version using Conda install Seaborn. Alternatively, you can use pip to install the development version directly from GitHub. Pip install git plus https, and this link is given here. Another option would be to clone the GitHub repository and install from your local copy. Dependencies has to be installed. That is Python 2.7 and R 3.5 plus dependencies have to be installed. It is mandatory. Here is an example for using the Seaborn. See here, numpy have been imported, Seaborn as SNS have been imported, and again here the style can be set, sns.set style is equal to white, and you can generate a random a univariate data set using random stata function. And you can plot here a simple histogram plot is used. So SNS dist plot d comma kde, that is equal to true, and color is equal to G. So G stands for green color, and the output histogram output is shown here. By importing the Seaborn, this program has been written in Python. Thank you.